Going twice. Okay, so sold. All right. So, at large quantities, chemical supply companies will react calcium carbide with water to produce acetylene and calcium hydroxide. If you begin with 5 grams of calcium carbide, how many grams of acetylene are produced? And part B, we could say, is how many moles of water are needed to completely react to form this acetylene. So we might be looking at some of these terms that we're saying, well, what compound is which? We'll just do a process of elimination. We know that for our equation, it says that this will react with water. So if it's reacting, is it on this side or this side?
Reacting side.
It's on the left side. So we know we've got CaC2, and it's reacting with water, which is, okay, sometimes you can do it. We're going to come back to that. You're right, but we'll come back to that. Okay? Then, just by a process of elimination, what do we have left that we have not accounted for that's up here that's not down here yet? Okay? And for anybody who's ever used a cutting torch, because some of you probably have that on your farm, okay? You're making this compound, okay? And then what is calcium hydroxide?
CaOH.
Okay? So what we were saying earlier is sometimes if you see a hydroxide on this side, and if you have water on the other side, or vice versa, if you have a hydroxide over here and water on this side, one of the things that you can do to help yourself out is just rewrite the compound, okay? Because what that means then is now you've got a hydroxide and a hydroxide over here. Okay, so it looks to me like the only place that we can start would be here because of those hydroxides. Okay? So if there's 2 hydroxides over there and only 1 over here, we'll place a 2 there. And then that gives us 2 hydroxides to our 2 hydroxides. And then how many hydrogens?
2.
So that must mean we're balanced then, right? Should you have chosen to break hydroxide apart, our simple math can tell us what's 2 times 1? 2 times 1. So that gives you 4 hydrogens there. So then distribute this 2 into here. 2 times 1 plus those 2, that gives you your 4 there as well. All right. Is that a gang sign or something? Feels like that. So, oh, okay, I just thought that. Okay. So, we got 5 grams of calcium carbide, 5 grams of this. So, how many grams of this are going to be produced? We don't know. All right. One of the things, this is one of those instances, if you did not balance this correctly, is that going to affect your answer in this problem?
Probably.
No. That's part of it. Because in your mole ratio, what coefficients are we using? 1, 2, 1 to 1. So that means that even if you didn't do that correctly, you'd still come out all right. Okay, so to start this out then, we've got 5 grams. And this isn't such a big compound to write out. Okay. So how do we get rid of this grams in our next step? Okay. Okay. Yes, I can hear that. Okay, so 40 plus what, 24? 64? Okay, 64.10. Okay, so for every mole of C2H2, get a mole of CaC2. Okay, so notice we said earlier it's 1 to 1. Well, I don't know, it might have been flashing, but the battery seemed to be just fine. Okay, then for every mole of C2H2, you get moles here. See, when you write this out, it tells you exactly where you are in the problem, which means when we look up here, it says we need to have an X amount of grams. So that has to be ending in grams, which is 24, 24 plus 2, 26.04. Oops. Okay, so then everything's canceled. You're left with grams of calcium or acetylene, which is this compound, and that's what we're looking for. Okay, so 5 times 26 divided by 64. Say that 2.03. Okay. Darn it, C2H2. Okay. So then for part B, all right, we don't need to reinvent the wheel, which means we don't need to take our eraser and wipe all of this out, okay? So like we said, since we're starting with 5, that number's the same, that number's the same. So is this one. It's just we're not looking for a mass, so we can get rid of that. And then do we keep either one of these? We keep this one. Okay. And then what isn't going to be on the test? Huh.
Probably in the part 2, maybe.
Sure, that's going to be on your test.
It's not even a test next exam, all right, dude?
Oh. Yeah, see, you got it. Yeah. Okay. Okay, so in this case, every time that you see a mole over a mole, which means, of course, it's a ratio, go back to your balanced chemical equation, which means, of course, this 2 here is important. You already had said that goes here. And then 10 divided by 64, I don't know, 0.3, I don't know. How much is it? 0.16, I was way off. 0.16 moles of water. Okay. So some of the things that can happen, okay, is if we were looking for the mass of that water, and again, you laugh, but we're going to see this because we saw it yesterday when it came to those Roman numerals, okay, is we may have moles of water here. If we were looking for the mass, and it's unfortunate, but we're going to see that. I'm going to say, oh, well, we've got 2 moles of water because there's a 2 here. Why is that in the wrong spot? because you are not having a mole ratio. It's only if moles are over moles. Right. All right. Just hopefully what we could visualize as a teaching moment, we hope. All right. That leaves you, what, 24 minutes or so? Is there, yeah, maybe give or take. Anything on that paper that you have in front of you that's due tomorrow is, oh gosh, I could use a little help on that. Percent composition? That's much easier than this. It's what you did earlier. Okay, we can put you, point you in the right direction. Okay. Because you solve, well, that's how we taught you. You solve those percent compositions fairly similar to these stoichiometry problems. Okay, so what do we, it's sodium carbonate or something like that, right?
Yeah.
Sodium bicarbonate. How much do you start with? It's 70 something? 0.35? Okay, so is it, okay, so it's sodium bicarbonate then, okay? So some of these just get common names like this here because CO3 is which polyatomic ion? Carbonate, which has a charge of -2, okay? What does hydrogen have for a charge? What does sodium have for a charge? Okay, so now that adds up to 0, so that's why sodium bicarbonate is wrote or written the way that it is. Okay, so what you need to do is I would suggest start with probably the most difficult element in this compound, which would be which one? Not sodium. Not carbonate, I said element. Not hydrogen. Not carbon. Oh, we finally got there. Yeah. Why would we say oxygen? Because you've got 3 of those. Okay, so this is why we solved those molar mass problems the way we did. So if you're starting with 71.35 grams, okay, we're going to say sodium bicarbonate because we got the formula right here. Okay? We have grams of sodium bicarbonate. How do we get rid of that in our next step?
48.
Yeah. So then when we add 48, 16 times 3, 12, and then we'll just put those two together, which will give you 24.01. Okay? And 0.01. Okay? So 10, 14, 1, 5, 6, 8. Is it 84.02?
Yep.
Okay. Is that? Yeah. Okay. 84.02. Because that simple math can sometimes get you every time. Okay? Grams of sodium bicarbonate gives you a mole of sodium bicarbonate. Okay? Then, this is moles of this entire compound. This is why we said this third step was so important, because it allows you to change what we have into what we're looking for. So we're going to pick oxygen because we said that was probably the most difficult to do, which I would agree. Okay? So moles of oxygen goes here.
48 grams.
Okay? And then, now, you're not wrong. Okay? It is 48. Okay? So this is where she's coming up with 48. There's one of two ways you can do this. Okay? But I highly, highly suggest that you keep this consistent with how we've done this so far. For the mass of oxygen, which is 16, okay, then you go back to your equation, and what we illustrated, that is where that 3 comes from. It was just good practice so that once we got to our reaction stoichiometry, you're used to looking back at here and putting numbers in there. That's why we do this the way we do it. There's always going to be a reason for that, we hope. Okay.
So we only do 16 grams of the oxygen, not 48?
Yeah, that's,
Because there's 3 moles.
yeah, okay. So you're going to get the same thing. But we wanted to practice this because, again, it was getting used to looking back at your balanced chemical reaction. That's why. Okay.
So what if you, what if you did 16 times 3 and just put 1 mole of oxygen?
You're going to get the same answer.
But would
But-
you count that?
No, I wouldn't count that wrong. Okay? So then, here again, you don't have to reinvent the wheel here.
Just erase the 3 and the 16.
Because this is the same, that's the same, that's the same, this is the same. It's just these 3 spots that you would change. Okay? So you can really keep it simple. Just leave the mole on there because every one of these, just 1 mole of carbon, 1 mole of hydrogen, 1 mole of sodium. Okay? So then if you did this, okay, we got to change that 16 to what does the periodic table tell you?
1.01.
Hey, when you get like a number, like when you solve it all the way out, don't you have to go back and divide that by the 71.355% of it? Or no?
Does it say percent or does it say how much?
Percent confidence.
Oh, right. So then with every answer you get, you divide it by 71. Yes, that's right. I'm sorry, I thought it said how many grams of each compound, of each element are in the compound. Okay. Yes, ma'am. Okay, if there's nothing else, the rest of the time then is yours to work on these. Yes.
So
All right.
everything is 1 but the oxygen.
That's correct. We'll catch up to you next time.